Okay, the purpose of this video is to look at the slopes of parallel lines. In the next video, we'll look at the slope of perpendicular lines. Okay, so first, parallel lines are simply lines in the same plane that never intersect. Okay, so let's look at an example here. I'm going to draw a couple different lines. So the first line I'm going to draw is y equals 1/2 x plus 1. Okay, and if I look at that graph, y equals 1/2 x plus 1, I'm going to go up 1 for the y-intercept, and then a slope of up 1 over 2, okay? Or I can do down 1, left 2, okay? So there's my line. Okay, and now I'm going to look at the graph of y equals 1/2 x subtract 2, okay? So I'm going to do a y-intercept of 2. I'm going to go up 1 over 2, up 1 over 2, okay? So my graph's going to look like that, okay? Both of these have a slope of 1/2. And this has a slope of 1/2. Okay, so we notice that if the parallel lines have the same slope, if the lines have the same slope, they're going to be parallel. So let's describe that over here. So we can simply say that, and this only works for non-vertical lines in this case. Non-vertical lines are parallel if they have the same slope and different y-intercepts. Okay, and then let's talk about vertical lines now. So vertical lines would be an example like this right here. Okay, let's say I take a vertical line like this one, and then I take a vertical line like this one. These two are parallel, okay? But we could say that vertical lines are parallel if they have different x-intercepts. Okay, and you can see right here, they do have different x-intercepts. If they happen to have the same x-intercept, then it's just going to be one line on top of the other, and we don't want that. So parallel lines are lines that have different x-intercepts. Okay, next example here, we're going to look at a line that passes through 12, 5 and is parallel to that given line. What equation represents a slope-intercept form? Okay, so we're going to start off with what our ultimate goal is. Our ultimate goal is to get y equals mx plus b. And we know from our work with slope-intercept forms that I need to know what my slope is and I need to know what b is. Okay, so we're going to go back up to our beginning and we're going to say, oh, I already happen to know that b is 2/3. Okay, so that gives us a piece of the puzzle. I can say over here that m is 2/3. Okay, and then we also know that x is 12 and y is 5. So I'm going to state that x is 12 and I'm going to state that y is 5. Okay, so I'm given a point, I'm given a slope. So this is a perfect case to use slope-intercept or point-slope form. So I'm going to plug into slope-intercept form. So I'm going to say, in this case, it's going to be y minus 5 is equal to a slope of 12 times, no, that was not right. The slope is not 12. The slope is 2/3. Okay, slope of 2/3 times x minus 12. Okay, now it asks for slope-intercept form. I'm in point-slope form, so I've got to do some manipulation here. So what I'm going to do is I'm going to distribute out the 2/3. So I'm going to be left with 2/3 x minus. Now 3 goes into 12 4 times. 4 times 2 is 8. So I'm going to get 8. And then I'm going to add 5 to both sides. And I have a final result, which is y equals 2/3 x subtract 3. Okay, so that is my final answer. Y equals 2/3 x minus 3. And these lines are parallel. They have different y-intercepts. And if I plug in 12 and I plug in 5, this is a true equation. Okay, that's the last example. In the next video, we'll look at perpendicular lines.